Physics 2212 Lab 1 Charge Tape by Justin Siegel. The purpose is to conduct an experiment in order to determine about how much excess charge is on one piece of clear tape based on its interactions with other objects. There are three main principles used in this experiment. First, Newton's second law to determine that the net force on the tape was zero due to the fact that there was zero acceleration. Coulomb's law was used to determine the electric force on the tape, and the gravitational force equation was used to determine the gravitational force on the tape. For the results, the tape had a charge of 1.3 times 10 to the negative 8 coulombs when the tape was considered a point charge. It was deficient of 8.1 times 10 to the 10 electrons, and the tape repel each other, so that means both had the same charge. A few assumptions were made when performing this experiment. Those were that the piece of tape acts as a point charge, meaning all the charge is in the center of the tape. Air resistance is negligible. The U-tape had an evenly distributed charge. All pieces of tape were the same length and width, and there was no other significant interactions besides the ones explained in this experiment. So for the experiment, the system was tape A and tape B. The surroundings were everything else in the room, and the initial conditions are two pieces of tape that are equal length and are neutrally charged, and a third piece of tape that's stuck to the desk. So for the procedure, tape C was stuck to the desk. Tape B was then stuck on top of it and quickly ripped off, which caused it to either gain or lose electrons. That had not been determined yet. Tape B was then held near my hand, a neutral calculator, and a negatively charged pen in order to determine the charge. Tape A was then stuck to tape C and quickly ripped off as well. Tape A was connected on one side to a desk and on the other side to a chair with nothing connecting it in the middle. Tape B was then placed below tape A until tape A repelled tape B, and that distance was recorded, as seen in figure 4. So the length of the tape was 0.21 meters, the weight being 0.00021 kilograms, and the distance between tape A and B were 0.271 meters. Since the net force on the tape was zero, the gravitational force equaled the negative electric force, both being 2.06 times 10 to the negative 3 newtons, yet the gravitational force was in the negative y while the electric force was in the positive y direction. The measured electric charge was 1.3 times 10 to the negative 8 coulombs, and the U-tape interactions, the U-tapes between each other repelled, the U-tape in my hand attracted, the U-tape in the neutral calculator attracted, the U-tape in the negatively charged pen attracted, which made me determine that the U-tape had a charge that was positive. The total number of atoms on tape B was determined by taking the surface area of the tape divided by the atom length, which resulted in 3.675 times 10 to the 17th atoms. The electron deficiency was found by taking the absolute value of the charge divided by the charge of a electron, which was 8.1 times 10 to the 10th. And the ratio of electron deficiency to atoms resulted in 2.2 times 10 to the negative 7th, which means that there was one electron per 4.53 times 10 to the 6th atoms. So for the first experiment, where the tape was considered a point charge, it can be seen that the gravitational force and electric force were the same, yet one negative, meaning it was in the opposite direction. The tape charge 1.3 times 10 to the negative 8, and electron deficiency 8.1 times 10 to the 10th. And for the second experiment, the line charge, it can be seen that the magnitude of the electric force changed, but the gravitational force was the same. Also, the tape charge changed a little bit. It got a little smaller due to the fact that the charge was spread throughout the entire tape instead of just at the central location. You can see that the electric field equation was used and created using a function, and all of my scalars were changed until the model looked most visually appealing. If the signs were reversed, not much would change. Both the tapes would be negatively charged instead of positive, but they would still repel each other. But in the free body diagram, the electric field would now point towards the negative charge instead of away from the positive charge. All opposite signs would attract and all similar signs would still repel. And the Q value, which is the charge value, is smaller for the line charge model, as I said earlier, because the charge is evenly distributed throughout the entire piece of tape instead of just being in the center of the tape. The value for the line charge is more accurate, as that is more realistic to determine the entire charge of the tape. So in conclusion, the main sources of error could be that the tape interacted with other aspects of the surrounding that were not accounted for in this experiment. The tape was not measured or weighed perfectly. Electrons were lost due to the interaction between the tape and my hand. The charge could have been different for each piece of tape, not always the same. So in conclusion, the line charge model produces more accurate results for the charge of the tape and for the electric force on the tape. And the U-tape had a positive charge, which meant electrons were transferred or removed from the tape during its interactions with other objects, such as my hand, calculator, or the other piece of tape. Thank you.